Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atika Sharina binti Sanimi. Today, I will present my research entitled Mathematical Modeling and Simulation of Boolean Risk Dynamic using Ordinary Differential Equation and the Range-Kutta Method. For the introduction, bullying is a serious issue in schools that can affect student mental health, academic performance, and social development. Most existing prevention methods are reactive, where action is only taken after bullying occurs. Therefore, this study developed an ODE-based Boolean risk prediction system using the Range-Kutta method and MATLAB GUI to support early detection and decision making. Next, we move to the problem statement. There are four main problems addressed in this study. Firstly, bullying cases are still widely reported, showing that current prevention approaches are not fully effective. Secondly, existing identification method depends mainly on report and teachers' observation after incident occur. Thirdly, school lack a systematic approach to combine multiple risk factors such as psychological, social, and behavioral actors. Lastly, there is no integrated system that combines risk prediction with resource allocation for effective intervention planning. Next is research objective. This study has three main objectives. The first objective is to develop an ordinary differential equation model for Boolean risk prediction. The second objective is to solve the model using the fourth-order Range-Kutta method. The final objective is to develop a MATLAB app designer dashboard for Boolean risk prediction and resource allocation. We move to the literature review key finding. Based on previous study, bullying is identified as a multi-factor problem involving individual, social, and school-related factors. Strong peer support and teacher involvement can reduce bullying risk. However, counseling systems still face limitations such as lack of resources and stigma. So for the research gap and contribution, existing studies mainly focus on statistical and descriptive analysis, with limited development of predictive model. There is also a lack of time-based dynamic modeling approaches and decision support system for school. Therefore, this study contributes by developing an ODE model to represent Boolean dynamic, applying the RK4 method for simulation, and creating a MATLAB GUI system that integrates risk prediction with intervention planning. Next, this study follows 5 main stages in methodology overview. So for the first methodology, which is the research design, this research applied a quantitative and computational approach. Boolean risk is represented using an ordinary differential equation where the risk level changes based on behavioral and environmental factors. The model integrates risk factors together with intervention factor. Next is model framework. So the proposed model describes the changes in bullying risk over time. The combined risk factor represent factors that increase bullying risk, while the intervention factor represent protective factor that reduce risk. When risk factor becomes stronger, bullying risk increases. Meanwhile, stronger intervention factor help decrease the risk level. So next, the model variable includes psychological distress, social media usage, peer fight, skipping class, teacher support, teacher appraisal, and helpful friend. Each factor is assigned weighting coefficient to represent its influence on bullying risk. So next, for the numerical method, the developed model is solved using the fourth-order Range-Kutta method. RK4 is selected because it provides higher accuracy for solving dynamic systems compared with simpler numerical methods. This method allows the simulation of Boolean risk change over time. Next, the risk stability index, represented as R0, is used to determine the behavior of bullying risk over time. When R0 is less than 1, bullying risk is expected to decrease. When R0 equals to 1, the risk remains stable. When R0 is greater than 1, the bullying risk is expected to increase. Next is GUI development. So the MATLAB app designer dashboard was developed to allow users to input student risk factors and intervention factors. The system automatically calculates the bullying risk score and provides the predicted risk category. So next is risk classification. So the risk level is classified into 3 categories based on the final score. A score below 5 represent low risk, a score between 5 and 10 represent moderate risk, and a score above 10 represent high risk. We move to the result and discussion. In the low risk scenario, the final Boolean risk score is 0.6111. The result shows that the risk increased initially before becoming stable. The recommended strategy is a basic awareness program with continuous monitoring because the student has strong protective factors such as supportive friends and teachers' involvement. Next, a moderate risk scenario, the final Boolean risk score is 5.113. The risk increased initially and then stabilized. The suggested strategy is targeted intervention through counseling, teacher monitoring, and peer support. The main contributing factors are high psychological distress, peer conflict, social media usage, and skipping class. Next, for the high risk scenario, the final Boolean risk score is 22.95. The risk increases continuously without stabilizing. Therefore, intensive intervention is required, including immediate counseling, close teacher monitoring, and strong peer support. Next, This explains the effect of risk versus intervention. The relationship between risk factors and intervention factor determine the bullying risk behavior. When risk factors are higher than intervention factor, bullying risk increases. When both factors are balanced, the risk remains stable, and when intervention factors are stronger, bullying risk decreases and the situation improves. So, in conclusion, this study successfully developed a bullying risk prediction model based on the ODE framework. The model integrates both risk and intervention factors to analyze bullying behavior dynamically. By using RK4 and MATLAB GUI, the system can simulate different scenarios and classify risk level effectively. This provides a useful decision support tool for early detection and intervention planning in school. For future improvement, real school data can be incorporated to increase model accuracy. Machine learning technique can also be integrated to improve prediction performance. In addition, optimization method can enhance resource allocation planning. However, this study is limited because it uses a sim parameter and has only been tested through MATLAB simulation. That's all from me. Thank you for your attention.